I just wanted to step in and thank Sigu, Tracy, Okof, and basically everyone else who has made ElixirConfAfrica possible. It takes a lot of hard work to put together a conference, especially during a pandemic. And when Tracy reached out and asked me if I wanted to keynote, it was a really exciting moment for me. Even though this was a talk I really wish I could have done in person. Most of you maybe know I spent some of my childhood years in West Africa, in Ibadan in Nigeria, to be more precise. My father worked there. In conjunction with it, we visited Cameroon, Benin, and drove all across Nigeria. Later on, my father moved to a small village in Senegal and spent many years there, again for work. And I visited many times. I've worked extensively in South Africa. So, whilst it's a pity we can't do this in person, but whilst the pandemic is not allowing us to meet in person, it is one thing it is doing is bringing us much closer together, thanks to events like yours, which you have organized. And so, it's the world might be big, but it is shrinking a lot, and we heard that also in the previous one. So thank you very much for putting together this event. It means a lot.
And thank you. I echo that completely. So thanks very much. So let's get started. And I guess where does this come from? We've gone in different directions, Francesco and I. I've moved from academia to having a more industrial view, Francesco in the opposite direction, perhaps. And we want to talk and reflect on that, about how that affects our view about how people learn and how people teach programming, and particularly functional programming. So Francesco, over to you.
Yes, so I think going back memory lane, which I tend to do every now and then, I taught my first course in 1998. So Erlang at the time had still not been released as open source, and it was mainly used within Ericsson. You could count the number of companies who were using it outside of Ericsson with the fingers on one hand, and actually you didn't even need all those fingers. And so if you wanted to work with Erlang back then, you had to work at Ericsson. And if you were working at Ericsson, it was very, very likely that you got pulled into an Erlang project. And so when I got the opportunity to teach, I was in between projects, and I wasn't really interested in teaching. I never thought it was something which would work for me. But what it did is it gave me the opportunity to travel to the States, visit Research Triangle Park in North Carolina, so Durham, Chapel Hill, Raleigh, that area right there. And en route, visit friends in Philadelphia, Washington, D.C., and New York. And, I had no experience in teaching and honestly didn't think it was for me. And I got in Monday morning, suit and tie, and the first thing I realized was that the class I was supposed to teach, did not want to be there. They were not interested in learning yet another proprietary programming language, which they could not put on their CV. And they kept on finding issues with the training material, with Erlang, the language, and with anything else they could criticize. They criticized everything except for my jacket. They would go in and point to spelling error on slide 121, to which I replied, hey, guess what? It's British spelling. And they countered by questioning why then in slide 109, we were using American spelling for the same word. And I think the highlight of that first week was when one of the students goes in and storms into the classroom, up to the whiteboard, and he goes in and just starts writing. He creates an object, he instantiates it, and calls the method hello world. So he had, with basically this much code, done a hello world in Java. And I went in and replied by writing IO colon format, hello world, and then said module, function, arguments. And he went in and said, but that's counterintuitive. But whilst his version of the code, which was his big, was intuitive, but he never failed to say why it was counterintuitive. And I had 3 weeks, which I had to spend in North Carolina, and I ended up turning the class around. At the end, they were all cheering, they all loved it. And I ended up getting the highest graded trainer at Erlang System, which was the department that Ericsson used to work with, had ever received, beating all of my much more experienced colleagues. And I'm still today not quite sure what was wrong with the class, but I do suspect that they had such a traumatic experience learning Java, they probably thought learning any other language would be as bad. And I was struggling to relate. You know, when I myself learned Erlang, it was fairly easy. We didn't have lectures. And you know, the professor came in and said, this is the book, read it, these are the exercises, do them. And off he went, teaching us of the theory. And yeah, I picked it up fairly easily, you know, probably because the second programming language I studied in university was ML. And so, yeah, it was ML. So, you know, with this insight, you know, I basically picked it up fairly smoothly, fairly easily, just by reading the book and doing the exercises. So, you know, fast forwarding a little bit, you know, once I started my career in the industry as a consultant in 2003, a friend of mine, Thomas Arts, who at the time was the head of the program at the IT University in Gothenburg, asks me to go in and teach his second year students. And Erlang at the time was a second language that they were learning after Java. And again, no problems. You know, if you struggled, there were concepts needed to get, but they picked it up. In a week, they knew it, and you know, they were doing fairly complex exercises with them. And in the decade which followed, you know, 2003, so the first year, I ended up teaching at the IT University about 700 students. And also, you know, for the last 10 years, I've been teaching a concurrent programming course for industrial master students at Oxford University. And there, you know, I don't teach them to program. I don't teach them a programming language. What I do is I use Erlang as a tool to explain the principles of concurrent programming. And as concurrent programming, and I basically teach them a lot of these principles and ideas and concepts, which they then apply in whatever language they're going to use in their day jobs. So Simon, what about you? What were you doing in the 90s? And how did you get into teaching?
Let's not talk about the 90s. Let's talk about the 80s. Because
80s, okay. I was still in high school. I was doing Pascal at the time.
Fine. Okay. We could even talk 70s, but let's not do that. Let's start in the 80s. So I started functional programming in the early 80s, working with David Turner at the University of Kent. And one of the highlights of the 80s was I spent some time living in Brazil, in Recife, in the northeast of the country. And that was with Rafael Lins, who you see in the picture. And we taught functional programming. And I was just thinking, what's the difference between teaching functional programming in 1988 to teaching functional programming now? And there are some differences, but there's quite a lot of similarities. I mean, what do we talk about? We talk about higher order functions. We talk about functions as arguments, functions as results, plugging together functions. We talk about how you can do cool things, building interactions, building parsers, and so on. And all of that we were able to do teaching functional programming on a mainframe. We couldn't do cool things with graphics. We couldn't do some of the things you might do with more complex interactions, but we could do all those things. And it was a very exciting time in some ways for computer science, because one of the really unusual things, and this is perhaps coming back, 50% of the course I was teaching were women. And you know, there's all we could spend a whole keynote talking about gender difference in computer science. But I think one of the major reasons was there were no home computers. So it wasn't that boys were playing games on computers and girls were feeling excluded, or whatever we talk about nowadays. Half the course were men, half the course were women. And you know, no gender differences at all, except typically the women were getting the top places in the course. So that was entirely different. So you know, some things. So we explain functions in the same way now as we did then, and that's, you know, I think it's an interesting insight that has not changed. And also, it's an insight that we think of computer science as being something that moves very quickly, but some concepts take a long time to filter. Now, you know, functional programming now is in pretty much every, you pick a language off the shelf, there's functional programming in there. JavaScript, Excel now has functional programming. You could define lambdas for yourself. But it's taken a while for those ideas to percolate out from these special purpose languages out into the mainstream. And the other thing that came out of that Brazil trip, apart from lots of great things, I taught a type theory course which became a book which I published 30 years ago. And that, again, it's taken 30 years for type theory to move from a sort of academic curiosity to something that people think of doing seriously in a language like Haskell. So Some things change very slowly, some things change very quickly. But Francesco, let's move back to your experience.
Well, my experience was more with your student, Simon. So if we continue, I was invited at the University of Kent to give a guest lecture for the students, which were studying Haskell. So they were studying functional programming. And they were giving the lecturer a very hard time. So he wanted me to go in and inspire them on how Erlang was being used in the real world. So from WhatsApp messages, to all of the way from calling the grandmothers from Canterbury to Edinburgh, all the way up into Scotland. So massively multi-user online gaming, annoying text messages your telecom operator sends you when roaming, or even TV voting on Britain's Got Talent and Big Brother. So all of that here in the UK was powered by Erlang. And so I went in and told them how it was influencing the day-to-day world, and it was managing a lot of the infrastructure, even though they didn't realize it. And after the lecture, I think one of the students, he was sitting alone in the corner, arms crossed, and any questions he asks, raises his hand and asks me, "Is Erlang any good for ASCII art?" And I stopped, processed the question, and look at him and go, "Sorry, I do not get the question. Could you please rephrase it?" Only to be met by absolute silence. After about 5 seconds of silence, another student who was sitting fairly close to him says, "Oh, what so-and-so means is that as part of our Haskell course, we had to draw ASCII art. As part of the exercises, you had an exercise where we had to draw ASCII art. You've just been telling us how Erlang is used around us, on how it's being used for real-world applications. Surely we should be learning Erlang and not Haskell." And so you can imagine the front row. This was a lecture room which was filled with quite a few students. The front row consisted of a lot of professors, lecturers, and researchers who were there out of courtesy to listen to my lecture. And they slowly started sinking in their chairs, slowly going down. And whilst I cannot read mine, I could read their expressions on their faces. And what their expressions were saying was, "Francesco, please get us out of this." And my answer was fairly straightforward. It was simple. I looked at these students and said, "You're not here to learn Haskell, Java, or Erlang. We're in the industry. The industry is moving so quickly that anything you're actually taught in university will probably be obsolete by the time you graduate." And this lecture was probably 10, 15 years ago, but I can still say today, you never stop learning. And what I told them is that what you're doing in university is, you're not here to learn, you're here to learn how to learn. And all of a sudden, Haskell, you learn Haskell, functional programming, just like I learned ML. Learning Erlang will be very, very easy. And hopefully, whilst learning Erlang, you'll also will have been exposed to concurrent programming, logical programming, imperative and object-oriented programming. So all of these programs. So any new languages coming along, which has been influenced by these, you should be able to pick up very, very easily. And, from my side, I'd never seen such an expression of relief in any of my talks as I did that day from the front row of all of the professors and lecturers, And actually, soon after that, some of the students did indeed reach out to me asking me for an internship. Because, why would I give you an internship? And, the right reply, because I know Haskell. So learning Erlang is going to be really easy. So, the bottom line or the moral of the story is that whilst in universities, we teach the students the foundations which allow them to stay on top of an ever-changing ecosystem, those in the industry are there to learn how to do stuff. And this brings us back to the first course I taught at Ericsson back in the 1990s. They were there to learn how to do stuff. They were not there to learn how to learn.
Okay, so Francesco sort of touched on this, and it's an interesting point. What should we be doing in universities? Should we be teaching principles? Should we be teach the lambda calculus, which some people say is the foundation of the functional languages that we use, or should we be teaching a particular functional language? And I think the answer is we should do both. I think the analogy I always have is about learning to swim. I mean, you can learn to swim by looking at videos, and you can listen to somebody talking about how you move your hands through the water and so on. But the only way you really learn to swim is by getting in the pool or getting in the water, getting in the sea, and actually moving your hands. And in the same way, I think we only understand how to use a tool, which is what a language is. We only understand how to use a tool by actually using it. We understand how to speak a language by speaking to people and using it to communicate our thoughts. And so we need to, in order to take the ideas of functional programming and get them to learn, I think one of the things that people have to learn in university is you don't learn everything from books. You learn by doing as much as you learn by thinking. And I think people sometimes think that universities, it's all in theory, but no, we teach a lot by people experiencing and taking those ideas and using them in whatever language is there. You could use Haskell, you could use Erlang, you could use Clojure, you could use Excel now. I don't think I'd recommend that, but I'm sure somebody is busily now building a nice environment inside Excel for teaching functional programming ideas. So I think in some ways the ideas can come from any language. But one thing that we need to do, I think, and this is where perhaps universities, but I think industry as well has to learn. It's easy to send people on a one-week course in industry. It's easy to teach people a course in university. People really only learn, I think, get a fundamental, a deep and reusable experience of a technology by following through. In tennis, if you want to hit the ball hard, your racket has to keep on that ball so it gets that extra acceleration. And this is something that I think in universities are not always terribly good at, but I think companies can suffer from this as well. You think, oh, somebody's been trained, we've sent them on that one-week course, they've got the certificate at the end, that's fine. Well, no, you've got to apply things. And the way that with our experience from Kent, one of the most pleasurable courses I've taught is a course on, we call it programming language technology. It's about building parts of a compiler, taking you from the source code to generating x86. And what we did in that was give students a tiny compiler written in OCaml, and we got them to extend it. We'd not taught them OCaml, they'd learnt some Erlang, because Francesco persuaded me and my colleagues we should teach Erlang. Though now I'm no longer teaching it, they've now persuaded themselves that they're going to teach Haskell instead. So people get wedded to particular languages, and we'll talk about that a bit later on. But the crucial thing about this course was to say, actually, your experience, you know how to program, you need to learn this language, and then you need to take this program, this existing program, and extend it. And that's like the experience of working in industry. Very few people start with a blank screen. Most people start with extensive libraries and all the mess that their predecessors and colleagues have built. They have to find their way into reading the code, understanding the code, extending it, embedding what they've done in different languages. And so this is something that I think it's a message that universities, I think, still need to pick up. But I think also, if you're thinking about how to train yourself, how to train your staff, doing the course is a great starting point, but follow up by getting involved with some open source projects. That's the way you'll really upskill yourself. And I was saying confer like it's 1999 because I gave a presentation at a conference in Nijmegen in the Netherlands about teaching functional programming in 1999 and said, this is what we should be doing. So again, some messages we've been talking about for quite a long time. And just one final anecdote that one thing that functional programmers talk about a lot, or have talked about historically, is the fact that it's much easier for programs written in a functional language, particularly perhaps a pure language, for you to prove that they actually prove mathematically. So not just test, but prove that whatever input you give them, they give you the answer they should. And we used to teach this as part of our course to our first year students. And I remember I had this fantastic student from Greece who could just get it. He was really, really good at it. And I said, I said, you're really good at this. He said, well, we've been doing this for 2,500 years. harking back to philosophers from Greece 2,500 years ago. I thought that was a very nice, a very disarming way of saying, we know what we're doing. Well, at least he did. I'm not sure all his compatriots knew quite as well. But Francesco, do you want to say a bit about learning styles?
Absolutely. Before I do that, I mean, this is not the revenge of the nerds, but the revenge of the functional programmers. I think, and finally, the world is listening to what we're saying. And as you say, we're seeing aspects of functional programming embedded in all mainstream languages. So if we look at different kind of teaching styles, when Elixir was a very young language, what Elixir is, it's a wrapper around Erlang. And what we did is we took our Erlang training material and we converted it to Elixir. And when we're teaching Erlang, we always started with the concepts and the theory. We were focusing on pattern matching, we were focusing on recursion, we were getting the students to start thinking concurrently. And these, we knew, were all of the main hurdles everyone faced when learning Erlang. So what we did is say, let's get rid of the hard stuff first, and we covered them in the first 2 days of a 5-day course. And the remaining 3 days, we just consolidate. We kept on building on all of these concepts, tying them all together, which resulting in systems which never fail and which were scalable. And with this approach, teaching Erlang, we never had any issues. We never had any pushbacks. Now, when we started taking this approach when teaching Elixir, the pushback started coming almost immediately, and it started coming not only from the student, but actually from the trainers. The trainers saying, we want to do stuff. We don't want to learn about the concepts. We want to get something end-to-end working. So, instead of teaching data types, recursions, funds, and then higher order functions in that order, as we did it, as we were used to do it in Erlang, we reworked the material. We had to go in and rework the material, and now we'll start with a higher order function, which shows you how you can iterate a list. So you start doing stuff. And once we've done that, we'll explain what a fun is. And once we've explained what a fun and you get it, we'll explain what a data type is. A fun being one of the data types. And then we go in and explain recursion. How do you actually write your higher order function using recursion? So, we basically swapped it around. And the approach, which, we were taking with Elixir is very much of a top-down approach versus the approach we've always taken in the Erlang world, which is a bottom-up approach. And, this is the typical, this, again, is very much cultural. It has very much to do with the background of those who were using Erlang back in the early days. And not only, but also the types of problems we were solving. If we had a project in Erlang, what we tended to do was we went in and we solved all of the hard problems first. And for the simple reason that if we failed at solving them, there was no point in continuing because the project itself was going to fail. And sure you will have heard Mike Williams give his talks, and if not, go search for some of his talks on YouTube. Mike Williams is one of the co-inventors of Erlang. You want to design by prototype, and if you want to fail in a small scale product, not in a large production system. And that was the mindset we were adopting. But in the Elixir space, that does not work. That didn't work at all. And the reason for it took us a while to realize, but a large part of the community came from a user interface, kind of user experience background. And they came on board and started using Elixir because of Phoenix, because of this amazing killer app, which has really helped spread Elixir. And as a result, they needed a top-down approach. They needed something working end-to-end from day one because they were using UI, UX. They needed to see what they were doing. They needed something working. And it was an approach which was based on libraries, which was based on dependencies, frameworks, and toolings, which allowed developers, to get on with their job. And they needed the visuals, so that they needed the visuals. And this was their background. And their brains were wired that way as well. So, whilst, Erlang and Elixir, and so whilst the two are very interchangeable and, and these approaches are very interchangeable and not very programming language dependent, top down versus bottom up, in my experience, the approach you pick is steered very much on the problems you're trying to solve. And you always need to ask yourself, how are we going to do it? And I've seen, the bottom-up approach fail sometimes when you needed something working end-to-end, and customers needed to see something and needed to ship fast. And I've also seen the top-down approach fail when, we started designing a very complex backend system as if it was a website. So, you really need to think about language choices and approaches. And, what do you think about this, Simon? What do you think about language choices and approaches when teaching?
I mean, it's complicated, right? I mean, I think you could, lots of people obsess about what's in this language, what's not in this language, and try and make choices on how the language behaves. But I think the choices are often made on other criteria. So you were just saying it's to do with the sort of applications that people are familiar with. Well, use a language that fits with those applications, and then you'll have people on board. If they're used to doing browser-based programming, do your functional programming in JavaScript, for example, or pure script. There are lots of options out there. So one question is going with the flow. Understand who you're talking to and use the language that's appropriate for them. But also there are things, it's not just what's in the language. It can be to do with the tools. How easy is it to take this language and install it, for example? Can you run it all in browser? Can you use REPL.it to teach it rather than people having to download stuff? People might want to learn it on a tablet or on a smartphone, not on a laptop. So there are all those questions. There are questions about how friendly it is. We used to teach when we first started teaching Haskell, the main implementation was an interpreter called Hugs. And that had it had loads of great properties. It ran on a PC, it was small, it was fast, but it had terrible error messages. And the worst was the one you see there, unexpected semicolon on line 4. And this was something typically a student would hit in the first week of learning the language, because Haskell is layout sensitive. Depending on how you indent things, a program can be correct or incorrect, or can actually change its meaning. So students would type their programs in and they get an error message. They write a 5-line program, they get an error message saying unexpected semicolon on line 4. And they'd say, this language is dreadful. They wouldn't say it like that. They'd say something much ruder. There is no semicolon on line 4. So how can I have an unexpected semicolon? Because there isn't one. The idea was that what the processor did was, before it did any parsing, it would pre-process to turn the indentation into semicolons, as you would see in a C-like language. So those semicolons got inserted, and if you'd laid it out wrongly, you got a semicolon in the wrong place. But why did the error message say that? So choosing a tool that actually fits what students want. And this moves on to whether you should teach a real language like Haskell or teach something much more scaled down, a teaching language. But doing that means you can introduce concepts one at a time, and you can get things like error messages that actually make sense to a beginner. Because using Haskell or Erlang or whatever, or Elixir, you're using a production language to teach people, and you want to give a different kind of error message to a beginner than you do to somebody who's experienced. So that can say, oh, just give us a teaching subset of Haskell or Erlang or whatever. And that I think people have thought about that, tried to do it. The only place it's really worked, in my experience, is the language called Scheme, which has now been renamed Racket, which has a wonderful environment called Dr. Scheme, Dr. Racket, that introduces features as you learn. So as you start as a small set of features, master those, you see there are more features, and the error messages grow as you grow. So that's it's complicated, but know your audience, I think, is a crucial thing there. So Francesco, do you want to say a bit about what we did next?
Absolutely. That is very much also a lesson we should have learned in the Erlang community, which we never did. We love cryptic error messages, but yeah. if we start talking about the collaboration Simon and I had, it started in 2001. So it was the very, very early days at Erlang Solutions. And back in the days, I used the royal we, even though it was only me. And I came in contact with one of Simon's colleagues on the Erlang mailing list, and visited the University of Kent. To meet the team and hear about all of the Erlang research which was happening there at the time. There's a lot of really exciting and interesting things going on. And speaking to the researchers, speaking to the PhD students, speaking to the professors, I quickly realized that it was all about programming languages. And it was not about how we do things in the industry. So they felt like there was a big kind of gap there in between. So a few weeks later, I had a spare day, so I came down and gave a one-day tutorial on OTP. So the middleware which we use to develop Erlang systems, and it was a topic I knew quite a bit about. I was on the R1 on the team which released the first release of OTP. Back in 1996, we were one of the first things I did at Ericsson. And I recall Simon didn't quite believe me that that's how we did everything, and maybe we started in Erlang and then migrated to OTP, but we convinced him in the end. And this resulted in not only a friendship, but also a cooperation around research projects. It resulted in a book in 2009, which we co-authored. In 2011, we went from being offline to being online. We recorded our first O'Reilly masterclasses, which was basically teaching Erlang online. And that was our first experience in a recording studio, 4 hours of video. And soon after, I think we started a knowledge transfer partnership around e-learning. KTPs are a way to get academia and universities academia and the industry to work together, where knowledge is transferred from the university to the industry.
Okay, and Sigu is saying we're hitting our boundary. So what I'm going to do is skim through in 1 minute the rest of our slides, and then we'll. So we did some nice work with Francesco. We built an online course, which Erlang Solutions taught, and we learned a lot from building. And after that, in collaboration with the University of Kent, where I was working, to design masterclasses based with me and Francesco, but also wonderfully with Joe Armstrong, who I'm sure most of you will know was one of the inventors of Erlang, and so many of his ideas have fed into Elixir. And I love this. This is Joe getting his face made up so he's not too shiny on the video. So we built an online course which is available 2 or 3 times a year on the FutureLearn platform. That's freely available, and you will be able to find it running again later this year. All the masterclasses that we made are also available for free all the time on YouTube. So if you search Masterclass Erlang and put in Francesco, or Joe's name, you will find those on YouTube. So we learned a lot from doing this. We learned different ways that people learn. We learned not to reinvent the wheel, reuse existing Erlang tools to help give us automated feedback when we were building tools. But we learned that automated feedback is not always the answer. There are some things where it's so much easier to talk to somebody, talk to other students, talk to your teacher. We also learned it was fun. We had lots of fun building the course. We had lots of fun interacting with people. And one thing that has come out of COVID is that loads of teaching now has gone online. Loads of conferences have gone online. And this has meant the world has really opened up. So I think for us, we were putting our feet in this water 5 years or so ago, but the world is, everybody else is there now. And so we're learning a lot from doing this, I think.
I think, the way we had done it up to then was asynchronously. We would teach, we would broadcast on YouTube, e-learning or whatnot. And what COVID forced us to do at Erlang Solutions is take the synchronous approach, which is what we'd always done in person. We had in-person courses. We could look at the students, we could engage them and see how they were doing. And it was COVID basically forced us to move our whole kind of in-person offering online. All our conferences online, and it's been a really, really interesting learning experience, getting the same effect and the same results through synchronous courses taught, we've taught remotely. But, that said, it has also, opened up a lot of opportunities. And this is a slide from the very, very first course which we taught, and it was 50% exercises, cameras on. We asked all of the students to keep the cameras on, names visible. Often we had breaks, and we ran 2 courses in 2 weeks, as well as our very first virtual conference. This was the week the UK went into lockdown. It was the week after I'd just flown in from the US, when the US was locking itself up from Europe. And I think, when we move our offering online, some doors were closed, but we believe many, many more doors were open. And this was a very typical example of us turning a negative into a positive. And this is a pivot point, and what will life be like after Corona? The coronavirus has forced digital transformation upon us. And whilst it has done a lot of damage to the world, there are positives which have come out of it. It shows that we're capable of, teaching the industry and teaching academically, remotely, whilst achieving similar results. This is for small groups. And whilst I miss, the pizza and the beer with my students whenever I teach them in person, that is just an excuse for networking, which we've now moved online. And so moving forward, I really hope it's going to be a hybrid of the two. We'll travel less, we'll work remotely from beautiful parts of the world with enhanced productivity and quality of life. And I'm speaking from my own experience, where last year, the last course I taught at Oxford University, there were students on my course, which, where they usually would have flown to Oxford. I had students in Australia, I had students in Thailand, I had students from Africa, and from the US and Canada.
Yeah. When we ran the online courses with FutureLearn, we had students from 120 countries.
Yeah.
And so if I visit somewhere, people say, oh yeah, we've met. I did your course in, I met a few people in Argentina when I was there, for example. So these things really open up the world. So I think there are, and I think there's no going back from that. I think COVID has pushed us in that direction. But I think it'll be a big mixture. There's no right answer here. There's lots of different approaches. People are trying things. I mean, the crisis has given people lots of reasons to think hard about how they doing things differently. And not everything is right, but the fact that we're having this conference is great. We would not have, this would have been a very different conference had we been doing it face to face. And so, I think it's an exciting time.
It is. I mean, and how we teach will be profoundly different in the future. And I think this is the future. It allows us to reach much larger communities, whilst doing what we love doing, without having an impact on the environment. All right. And great. This is it from us. I'm just checking if there are any questions. Do we have time for questions, Sigurd?
Unfortunately, we've completely run out of time, so
it's okay. I'm Italian. You can blame it on my Italian schedule. It's okay. We will answer the questions in the app. So if you do have any questions, please post them in the Wova app, and we will answer them there asynchronously.
And if not, find us, send us an email. We're on Twitter, we're on Facebook. So do reach out. We're happy to talk. So thank you very much for being patient with us, talking for too long, and it was great to meet you all. Thanks very much.
I hope we'll be in person next time. Thank you.
Yes, thanks. Bye-bye. Bye.